Commentary will start when NASA turns on their cameras for the actual drop test, and then I will start commentary.
Don't have nobody to call my own. Please turn on your magic beam. Mr. Sandman, bring me a dream. Bring me a dream. Cutest that I've ever seen. I've ever seen. Bring me a dream. Cutest that I've ever seen. I've ever seen. I've ever seen. Make him the cutest Everybody's like tonight all over. So long, don't have nobody to call my own. Please turn on your magic beam. Mr. Sandman, bring me a dream. Bring me a dream. The cutest that I've ever seen. I've ever seen. Bring me a dream. The cutest that I've ever seen. I've ever seen. I've ever seen.
Okay. Commentary starting now. We're just waiting for NASA to turn on their cameras so we can use those, because I do not have cameras anywhere at rocket launches. I just use the company's cameras that are given. So, from what I know, it's just the Orion capsule, which is going to take humans back up to the moon in 2024, they said, or for the Artemis missions. They're doing a drop test, and I have no idea what the actual thing is. I'm just looking at all the data that I was given. Hydro Impact drop test. Yeah, alright. So it's just basically just testing and what's actually going to happen with the whole thing and how it's going to go. Which, hopefully, it should go well, because we have a lot more advancements than we did in 1960s when we actually first landed on the moon. But, and then the also plan is for just putting more, like a space base or whatever it is. I don't know much about Artemis. I still gotta look or get filled in with it. I know a lot about other launches and missions though, so but still gotta learn more about Artemis before I do anything with that. If you can barely hear me, just turn up your volume, because my mic is not that good, but and it doesn't have a way for me to manually turn it up except for an OBS, which it's on max in OBS. So if there's also any audio problems or video problems, just tell me in the chat, because I'm monitoring that also. So yes, this camera should go on in about 2 minutes, and then I'll switch over from the broadcast starting screen over to the actual cameras. Let's hope this test actually goes well. Okay, yeah, we have 2 minutes till NASA's cameras turn on. So we're just gonna wait till then, and then once they actually do, I'll probably mute every couple of minutes, because of course the actual engineers at NASA are gonna be talking through their camera footage, so they'll know a lot more about me, and I don't want to interrupt that. Yeah, it's looking good for the test today though, and I'm not really good at commentary, so I don't know what to say, because I don't have a script for any of this or anything. So, but from the data, it's a 14,000 pound test version, so it's not the actual capsule, it's just a test version. And it's at Langley Research Center. I don't know if I pronounced that right or not. In Hampton, Virginia, or whatever it is. I'm bad at pronouncing stuff. Okay. So let's take place 1:45 p.m. EDT today, which is in 1 minute. So we're just waiting for their cameras to turn. Like I said, I'm going to mute now, and I will unmute when it's time.
Then tell him that his lonesome nights are over. Standing not so alone. Don't have nobody to call my own. Please turn on your magic beam. Mr. Sandman, bring me a dream. Ding, 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 ding. Bring me a dream. Cutest that I've ever seen. I've ever seen. Bring me a dream. Cutest that I've ever seen. I've ever seen. I've ever seen. Bring me a dream. Making the cutest that I've ever seen. Everybody's lonesome nights are over. Standing so alone. Don't have nobody to call my own. Please turn on your magic beam. Mr. Sandman, bring me a dream. Bring me a dream. Cutest that I've ever seen. I've ever seen. Bring me a dream. Cutest.
So there's currently a delay with camera turn on apparently, and we're just still waiting for that if you're just now joining into the stream. That's why if you join and I'm muting just your music, is just because I'm waiting for the actual cameras to turn on so I can actually start commentary more. But yeah, just right now it's just waiting at this point. So I'll go back to being muted until cameras actually turn on.
Young killer with young killer with
Feel the momentum. It is undeniable. We are going. And together, we will see Artemis light the way.
Our mission to the moon is no longer some far-fetched dream. This is reality. We are going.
This is the next step in evolution.
They're not just PowerPoint slides. They're actually metals being bent, shaped, formed to build the things that we're going to use.
This is real. This is going to happen. We're going.
We are going to the moon to learn how to live on other planets for the benefit of all.
Let's go.
Hello and welcome. We're here at NASA Langley Research Center in Hampton, Virginia. We're about to drop this 14,000-pound Orion crew module into our Hydro Impact Basin. I'm Allie Olney, and I'm here with Debbie Korth, the Orion Crew and Service Module Manager, and Jacob Putman, a data analyst here at Langley. We're here to talk about Orion and everything that's going on with it. We want you all to join us in this conversation by asking questions in the comments below. So make sure to put a hashtag #AskNASA. So let's get started. Debbie, can you tell me a little bit about Orion and what we're testing today?
Yeah, sure. Hi, Allie. Hi, Jacob. It's great to be here today and really excited for the test that's going to be starting up behind us and not too long from now. So Artemis is charged with taking the first woman and the next man to the lunar vicinity. And Orion is a big part of making that architecture happen. So Orion is the spacecraft that's designed for deep space. In fact, it's the only spacecraft we have that's specifically capable of bringing crew members back from the vicinity of the moon back to Earth. So a little bit about Orion. Orion is comprised of about 3 modules, the launch abort system, the service module, and the crew module. So the launch abort system is designed to take the crew module away from the launch site or the rocket in case there's an emergency.
Going over what
Otherwise,
the Orion
it
capsules,
detaches
or
from
Orion.
the spacecraft, and the crew module and service module continue on their journey to space. Once in space, the service module provides all of our propulsion and our power for the entire spacecraft. It also provides what we call services, like our fuels, our oxidizers, all the commodities, our gases, our water. All of that's stored in the service module, and it stays connected to the crew module for most of the duration of the mission. And then the crew module itself is the habitable volume where the crew actually lives. And so it's designed to house 4 crew members for up to 21 days, and it provides everything that they need to live and work in space. So you got environmental control systems, life support systems, all your guidance and navigation and control, your displays, and then the things the crew needs to just actually live. You've got a galley and an exercise device and a bathroom. And on the outside of the crew module, we have thermal protection systems that protect the crew and the vehicle upon reentry at the high temperatures that they see. And finally, a parachute system that deploys and slows that crew module down as it enters the water for its splashdown. So that's basically what we're testing here today. The water impact tests are looking at dropping the crew module in a variety of conditions, looking at how the structure responds to that water landing, which is a pretty significant event for the crew module.
That's awesome. Thank you, Debbie.
Yeah, sure.
So we're standing here at our gantry. Jacob, can you tell us a little bit about this facility?
Sure, Allie. So today we're going to be dropping the Orion test article into the Hydro Impact Basin here at NASA Langley.
I'm trying not to just use our cameras and audio, but they're going over stuff that I do not really know about and cannot confirm, so I'm just playing this, and there's some audio problems also with this.
So that we
So I'm
can
just playing
ensure
this so you
future
know what
spacecraft
this is all about.
are able to return our astronaut crew back to Earth safely in water-based landings. Now, the Hydro Impact Basin measures over 100 feet long, 90 foot wide, and 20 foot deep. And at its completion in 2011, it was filled with 1 million gallons of water. Since the completion of the Hydro Impact Basin, we've tested the Orion spacecraft in a variety of impact conditions, as Debbie mentioned, which has allowed us to ensure that no matter how the vehicle lands in the water, it will do so safely for our crew. In addition to testing Orion, we've also been able to test some of the commercial crew program vehicles out here at the facility, really ensuring that no matter what spacecraft our astronauts are in, they are able to return to Earth safely. One other thing I have to mention about this facility, because it's very interesting and unique about it, is that the Hydro Impact Basin is actually located at the west end of the lander test facility here at Langley, otherwise known as the gantry. The gantry was actually built in the 1950s or 60s for the Apollo program and used as a lunar simulator. So the first astronauts actually learned how to land the lunar module, as well as first learned how to walk on the moon here at this test facility. So super interesting and unique test facility, and really excited to see another historic test be performed here today.
Thanks, Jacob. That is so exciting. And as you said, we have had many Orion tests already happen here. And Debbie, the Orion crew module is already down at Kennedy Space Center, ready for Artemis I. Can you tell us why we're testing again today?
Yeah, sure. That's a great question. So, yeah, we have done a series of test campaigns at this facility with a series of different modules for the crew module. The article we have here today is called our structural test article, and what makes it different is exactly identical to the actual flight structures that we've delivered to Kennedy, and we're in the process of building up there.
There may
so
be
it has all of the
video and
flight-like
audio
pressure
delay for
vessel,
you.
the
I
back
have no
shells,
idea.
the heat shield structure. Also contains a lot of secondary structure and mass simulators for different components that would be installed inside the crew module. So it's a much higher fidelity model that we'll be using for this test. What it allows us to do is look at how the loads are transmitted into the vehicle and ensure that our load predictions and our margins for the vehicle are sufficient and good for our flight vehicles. So that's the difference with the vehicle we have today.
Wow. And so what's next for Orion?
There is a lot going on Orion right now. It's a very exciting time to be in the program. So for Artemis 1, as you mentioned, our crew and service module have already been delivered at the Kennedy Space Center. They're in the process of getting all of their commodities loaded, so the fuels and oxidizers and all the gases needed for flight. After that, it'll move on to a launch abort facility where we actually installed the last Artemis 1 LAS on top of the crew and service module. And interestingly enough, the actual launch abort system was designed and built and managed out of here at Langley Research Center. So it was the first module that we delivered for Artemis 1, and it's been at the Kennedy Space Center awaiting the crew and service module, which is now ready for integration. So after that, it goes to the vertical assembly building, gets installed on the SLS rocket that'll be showing up later this year, and all headed towards our uncrewed launch by the end of the year. So really excited to see that Artemis 1 vehicle go into a long trip around the moon. Artemis II is also well into fabrication, so the crew module is being outfitted with all of its environmental control and life support systems. The prop systems are being welded into that vehicle. The TPS, the thermal protection system, is being installed. So that vehicle is well on its way to coming together. And the parts of the service module we have parts of our service module that actually come from Europe. It's the European service module. It's kind of the guts of our service module, the prop system, and that'll be delivered later this year. All of that follows the very similar path, gets integrated, and similar path as Artemis 1, goes to the rocket, and it's targeted for launch in 2023. And finally, we've already started fabrication and build-up of the Artemis 3 unit. So just really exciting time to be in the program. Lots of vehicles being built, lots of testing being done, and really great.
Absolutely. No, we are so excited for all of this testing and all that is to come for Artemis. So back to our Artemis test today, or our Orion test today. Jacob, can you tell us what we're going to learn from this test today?
Sure. So we actually have over 500 sensors integrated into this test article. We really split those sensors into two categories. We have sensors which are intended to measure the forces that are acting on the test article during the impact event, and we're also measuring the motion of the test article as it moves through the water during the landing. So these are really going to tell us two things. Those forces are going to tell us a lot about any risk to the structure of the test article or any components inside of it, and the motion of the capsule through the water is going to tell us a lot about what the occupants inside might be experiencing. So really, with this test, we're ensuring that both the test vehicle or future Orion vehicle, as well as the occupants inside, are safe during any future landings.
That's so great. And so there's obviously a lot of preparation behind us going on. Can you tell us all that went into getting Orion ready for today?
Sure, yeah. So the test today is going to be really short. Dropping into the water doesn't take a lot of time, but there's a lot of work that goes into preparing this test article before it gets to what you guys are going to see today.
At this point, I wonder how much
test article
money is
itself
spent
was
on these
developed,
test
built, and
capsules alone
assembled
just to be
by
dropped in the
Lockheed
water.
Martin. At its completion, it was shipped out here to NASA Langley, where we integrated all the sensors. We attached them into our data acquisition systems, hooked them onto power, sealed up the capsule, and then prepared it for testing. Actually, prior to this test, we performed a checkout test a couple weeks ago, just to make sure we were getting all the readings that we expected. Everything checked out fine, so we are ready to begin our test today. So looking forward to it.
Yeah, and we're so excited. I think the test is gonna start soon. We might have to take some questions from social media. So I hope you all have been commenting and using the hashtag AskNASA. Let's go to some questions. Debbie?
Sure.
What will be the splashdown velocity of the Orion spacecraft?
In nominal conditions, when we're actually on a mission, I think the nominal speed is about 10 miles per hour, so it's pretty slow. It can get up to around 20, 25, and so the parachute system does a really good job as it comes through the atmosphere. There's chutes that deploy a forward bay cover, and then drogue chutes that deploy, and the main chutes deploy. So there's a series of parachute deploys that slow the vehicle down to a very safe landing speed. As far as the test today, I think it's about 16 miles per hour. Yeah, we'll have to get back on the exact number, but yeah, it's somewhere in that ballpark. Looking at the specific landing speeds, we actually vary the velocity and vary the angle of impact of the vehicle in the water to try and capture all of the envelope that we need to design towards.
That's amazing. And so, what's the difference between a hydro impact basin and a sloped swimming pool?
Well, the Hydro Impact Basin is flat at the bottom, for one, and it's also much larger. So the volume of water that goes into it, which again, 1,000,000 gallons of water, is needed to ensure that we can test high velocity impacts into the water and basically make sure the capsule is not hitting the edges of the pool. So those are kind of the primary differences there.
And do you know, is the basin saltwater, and how deep is it?
So it is 20 foot deep, and it is not salt water. It's a mix of light bit of chlorine, but mostly just normal tap water with some chlorine in it to make sure it's clear for underwater cameras.
Not made for swimming, though.
No, not made for swimming.
Jacob, what is the team looking for to qualify today's test as a success?
So to qualify the test as a success today, we want a nominal release from the hook. So we want to actually see it drop into the water. After that, as long as it pops out of the water afterwards and we get all the data that we intend to get out of the test, it will be everything we're looking for.
That's great. So Debbie.
Just a reminder that all these questions do not come from me.
As you can hear, we're about 2 minutes away from the splashdown test, so I think we'll keep taking some questions from social. So make sure you're still leaving those comments down below and using hashtag AskNASA.
2
Debbie,
minutes.
When Orion splashes down, how fast will it be going? Or how fast will it be going?
I think the range is about 10 to 20 miles per hour. And like I said, the parachutes do a really good job of slowing down the vehicle on impact. We also have inside the vehicle to protect the crew what's called the crew impact attenuation system. So think of like shock absorbers on your car, or maybe like your if you have a mountain bike, something like that. So it actually it softens the impact of the vehicle when it lands. So not only very, very smooth and not very much dynamics there.
Not getting all jostled around as they're landing.
No. They have very nice crew attenuation and nice cushioned seats that help attenuate that load into the crew member. Yep.
Great. And I think we have maybe time for one more question. How long will it sit in the water once it hits the water?
The nominal recovery is pretty quick. I think the requirement is it can be there for up to 2 hours, but we actually have recovery crews on site that get to the vehicle almost immediately, extract the crew, get them back on the recovery ship, and then actually tow the vehicle back into the recovery ship for deconfiguration. And actually, starting with Artemis II, we'll be reusing those crew capsules. So
awesome. Well, thank you. We're gonna get to this
you.
test.
Alright, so now this is where the actual test is happening.
15, 14,
Oh.
13, 12, 11, 10,
10 seconds.
8, 7, 6, 5, 4, 3, 2, 1, release.
That wasn't as big of a wave as I thought it would make, nor higher than I thought it was. I thought it'd be higher than it was there. A lot different than I thought these crew capsule testings would be. That's for sure. Did all those cameras get splashed? Because that deck was like clear and dry like a second ago, and now it's just all wet.
That was amazing.
yeah, it was really cool. What'd you think?
Yeah,
How's it look?
perfect. Yeah, can't get better than that. It looked like a perfect release, and yeah, it looks like capsule behaved as expected.
That's so great to hear. So I think we are gonna try and take a couple more questions from social, and then maybe possibly see a replay of this drop. Let's see. So
Drop tests are very short, by the way. I'm just muting the audio from the stream. They are very short. So, because of how short they are, it's really the end of it now. But we're just going to watch this replay. And then in a bit, I'll be ending the stream just because we've already seen the test. And the data will be coming out probably in a couple days, which you can find on the website below, confirmedspatialaunch.ml. I will add all the data and everything to that site once it comes out from NASA, either in a couple of hours, tonight, or maybe even tomorrow. And just another thing is that tomorrow the Starlink 24 mission will be streamed also with commentary. So, and that the stream starts at 12, I think I said it, and the actual launch is at 12:34. It'll be around an hour to 2 hours, and it'll be with the Starlink missions, which is a global broadband satellite mission. Because this is the actual end of the test and we've just seen it, I will be ending the stream here. Like I said, Starlink 24 missions tomorrow, 12:34 p.m. Eastern Time. So I guess I will next see you guys then. And like I said, there will be commentary. I will be doing everything over that. So I will see everyone.